بسم الله الرحمن الرحيم. طيب, firstly, let's put the rules for naming nomenclature of organic. Number one, choose the longest carbon chain.
مستر انا مش شايف حاجه.
اوكي, طب ثانية اتأكد كده. بسم الله الرحمن الرحيم. Okay, firstly, choose the longest carbon chain and give it name according to Latin number. Number two, give number for the carbon atoms in chain from side which. Number one, gives lowest number for branches. Side that take care from alphabetical arrangement if the number of branches give same sum from each side. From side near to double or triple bond. Number three. No. Okay. Number three. Branches. Alkyl, halogens. For alkyl, we said the name of the alkyl, name of alkyl precede by number of carbon which it founded. For the halogen, Cl, Br, I, F, so it will be chloro, bromo, iodo, fluoro. Let's looking for the some common name, some common name. Thirdly, means that the carbon atoms taking the shape of this letter T, shape of letter T. Iso, mean that the carbon atom take the shape of letter L. Okay, let's take an example for each one. Choose the longest carbon chain. Firstly, we're going to have 1, 2, 3, 4, 5. If we look to this shape, maybe the choosing the long carbon chain, it will be 1, 2, 3, 4, 5. Maybe 1, 2, 3, 4, 5. Maybe 1, 2, 3, 4, 5, 6. So it will be the longest carbon chain. So in all cases, choose the longest carbon chain. The carbon atom that out from this longest carbon chain or connector of the carbon atom, it will be branches. So carbon atom in this case, it will be branch. Carbon atom in this case, it will be branch. Give the Latin. Give the carbon atom, give it the name according to the Latin number. So it will be Miss S propupent hex. So it will be hexane. It is the longest carbon chain. Give the number of the carbon atom from the sides which gives lowest number of branches. Lowest number of branches, so it will be maybe counting from this side 1, 1, 2, 3, 4, 5, 6. So it will be 1, 1, 2, 3, 4, 5, 6. So we'll find in this case a branch in the carbon atom 4. If we're taking from another side, it will be 1, 2, 3, 4, 5, 6. So in this case, we'll find the branches in the carbon atom number 3. So we will counting from this side. Take care alphabetical arrangement. Where if we're talking about the branches, for the branches according to this, so the name it will be 3 in the carbon atom number 3, and else in the carbon atom number 3, dimethyl. So we can adding this rule number 5, repeating our repeated branches in same carbon atom take prefix di, tri, tetra. Like in this case, we'll find 3 and 3. We repeated the numbers in the atom number, carbon atom number 3, and else in the atom, carbon atom number 3. We have a dimethyl, dimethyl. Give the number from the side that take care from alphabetical arrangement. So if we have 1, 2, 3, 4, 5, 6. So we'll find the chlorine atom on this side and methyl atom from this side. If we numbering from each side that giving the lowest number of alternative or the branches, so we'll find from this side 1, 2, 3, 4, 5, 6. So we'll find the branch in the carbon atom number 2 and the 5. 2 plus 5 gave us 7. If we numbering from this side 1, 2, 3, 4, 5, 6. So we'll find the branch in the carbon atom number 2 and else in the 5. 2 plus 5 equal 7. So we may be said that the numbering from this side or from this side is not giving the problem, since the alternative or the branches have the same number for the sum of the branches, 7 and 7. So we must take care from the another point of view that giving the lowest numbering for the alphabetical arrangement. So we'll find the branches chlorine and the methyl, C and M. C preceded M in alphabetical arrangement. So we're giving the number according to 2. So it will be the name in this case 2 chloro dash 5 methyl, then the longest carbon chain, Miss proputpent hexane. Okay. Take care from the double or triple bond and determine the position of the double or triple E bond. Position of the double or triple bond. So if we're giving the name for this, like this compound, it will be C, C, double bond C, 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 and C. Maybe when having a branches, Cl, CH3. According this, we will numbering firstly according to the double bond, not according to the alphabetical arrangement. So according to the double bond, 1, 2, 3, 4, 5, 6. So we said alphabetical arrangement start firstly 5 chloro, 4 methyl, 2 or 3 we determine the position of the double bond or the triple bond. 2 between the carbon atom 2 and 3, so it will be 2. Between the carbon atom 1 and 2, it will be 1. So in this case, between the carbon atom 2 and 3, so it will be 2. Mes is proputbent hexene. Why ene? Because when having a double bond. طب if we replaced by triple bond, so it will be hexine. Okay. For the some common name like the tertiary and iso, let's talk about an example in the Zomdal test bank. So it will be slide number 3. Or slide 2. Second slide. Okay. Let's look at an example for the Zomdal test bank. This is an example for the compound that is incorrectly in the naming. For the example number 7. A student gave the molecule the following name: 2-methyl 4T, it means tertiary butyl pentane. However, the teachers pointed out that although the molecules could be correctly drawn from this name, the name violates the IUPAC rules. The name is violates يعني opposites the IUPAC rules. What is the correct IUPAC name for this molecule? Firstly, we must draw it according to the name that we are given. Okay, firstly we'll start by giving it the name. Okay. According to the wrong one, we'll draw it according to the wrong one firstly. So name again: 2-methyl. Firstly, draw according to the longest carbon chain, pentane, Miss S prop but bent. Counting from any number, or giving the number from any side, 1, 2, 3, 4, maybe 1, 2, 3, 4, no problem. In the carbon atom number 2, when have a methyl, it means CH3. And on the carbon atom number 4, 1, 2, 3, 4, when have a tertiary butyl, it means that the range of the carbon atom like this shape: C, 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 C. In this case, we'll find the carbon atoms taking the shape of the T letter. So it will be the arrangement, it's correct arrangement. Okay. Now we'll draw the compound. It will be H, 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 H and H, H and H, 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 and this is H. Now we want to determine the longest carbon chain. The longest carbon chain, in this case, it will be this. Let's draw it by another way to be clear to you. 1, 2, 3, 4, 5, 6. 5 only? 5. And in this carbon atom, 1, 2, 3, 4. And this carbon atom, 1. Firstly, choose the longest carbon chain. Longest carbon chain may be this is the correct one, maybe straight one. No problem if you're taking the longest carbon chain like this, since it's contained the largest number of the carbon atom. So the largest number of the carbon atom, it will be 1, 2, 3, 4, 5, 6. We're numbering from this side or from this side. Firstly, when you start to giving the numbering, search about the carbon atoms that making crowdedness. دور على ناحية الزحمة, crowdedness. So it will be 1, 2, 3, 4, 5, 6. So in the carbon atom number 2, we have methyl and methyl. So 2, 2. And carbon atom number 3. So we'll find 3. And the carbon atom number 5. So we'll find 2, 2, 3, 5. Tetra. Tetra what? Tetramethyl. Miss S proputbent hexane. This is a correct name for this compound. So the correct name for this compound, it will be letter B. 2, 2, 3, 5 tetramethyl hexane. Let's talk about another examples. What is the compound whose the carbon skeletal news any hydrogen atom appears pure? Type. Let's start to giving the name of this compound. I'm giving the name for this compound. Longest carbon chain. Where is the longest carbon chain? 1, 2, 3, 4, 5, 6, 7, 8. Start giving the number from the sides that have the crowdedness. So it will be 1, 2, 3. شباب اللي مشغل السماعة معايا ممكن يقفل السماعة بتاعته، أنا مش عاوز أسمع الريكورد بتاعه. أنا I'm start to record only. 4, 5, 6, 7. Maybe counting from the other direction. 1, 2, 3, 4, 5, 6, 7, 8. If we take care, I'll take this right. So we'll find the carbon atom number 2, we'll have a branch, plus carbon atom number 4, we have a branch, this is considered the branch. And in the carbon atom number 5, we have a branch else. And in the carbon atom number 6, we have a branch according to the red counting. For the black counting from this side, when I have the branch in the carbon atom number 3, and the carbon atom number 4, and the carbon atom number 5, and the carbon atom number 7. If we counting 3 plus 4, 7, 7 plus 5, 12, 12 plus 7, 19. From this side, 2 plus 4, 6, 5, 6 of 5, 11, plus 6, it will be 17. So it will be the correct one. According to this, so firstly, when we have a branch, maybe one carbon atom, it's called the methyl, two carbon atom, it's called the ethyl. So let's clean this. We start to counting from this side, so it will be 1, 2, 3, 4, 5, 6, 7, 8. We have this branch, it's called the ethyl, and this branch is called the methyl. Alphabetically, methyl, ethyl precede methyl, E precede M. So in the carbon atom number 4, we have ethyl dash. In the carbon atom number 2 and 5, 2, 5, and else in the 6, we have the methyl, but we have 2, 4, 6 for the same branch. So trimethyl dash. Longest carbon chain, mes, s, prop, but, pent, hex, hept, oct, octane. This I think for the rules. But if we are giving the name for the benzene compound, let's talk about the rules for the benzene compound. Benzene compound. Name of benzene compound. Firstly, for benzene only, this is called benzene. If we have OH, it's called phenol. OH, it will called the catechol. 3OH called pyrogallol. For the IUPAC name, it's called hydroxybenzene. This is called 1 and 2 dihydroxy benzene. This is called 1, 2, 3 trihydroxy benzene. If we have a carboxyl group with the benzene, so it's called carboxy acid or carboxy benzene. Or benzoic acid. To not waste the time, the naming of the benzene and its derivatives, maybe benzene may be monosubstituted for the benzene, maybe monosubstituted, maybe disubstituted, maybe more than one substituted. When having the name, this is when having lectures. I will send it to you I will send for all of you how to naming the benzene compound. Now we need to determine aromaticity. This compound is aromatic or not? Aromaticity. From where we can determine this compound is aromatic and not aromatic. Aromaticity, we can work on the rule, it's called Huckel's rule. In the Huckel's rule said 2n, 4n, I'm sorry, 4n plus 2 equal number of pi electrons. And this electrons must be integer number. This equation, when you will start to solve it, and we will take an about the example for it. It must giving to us integer number 2, 4, 6, 8, 10, 16, 14, integer number. Okay. Number 2, decollized. What's meant by decollized? Before decollized cycle, the compound taking the shape of the cycle. Start from 3, 4, 5, 6. Must giving the cycle. Decollized, it means that we have a single, then double, then single. It's meant by decollization of electrons, like in the benzene. What's meant by decollization? Single, double, single, double, single, double, and so on. If we not, we'll find for the carbon atom, in chain, must have at least double bond or positive or negative charge. Let's take an example. For this compound, it is aromatic benzene. Aromatic or not aromatic? It is a cycle. So, firstly, cycle. If one of this rule are not adapted, it will be not aromatic compound. Cycle. Decollized. Double, single, double, single, double, single, decollized. Each carbon atom at least contain one pi bond. So, double, single, double, single, double, single. For this carbon atom, it contains one pi bond, single. This carbon atom, one pi bond. This carbon, one pi. This carbon, one pi. This carbon, one pi. This carbon, one pi. So we'll find carbon atom, at least it may have pi bond. Maybe we'll find sometime carbon atoms that contain positive or negative, like this compound. Okay. Huckel's rule. Firstly, 4n plus 2 equal the number of pi bond. Pi bond, it means that the double bond. 1, 2, 3. Pi bond, counting by the electrons. The pi bond, each pi bond it contains 2 electrons. So 2 electron, 4, 6. So it will be 6. So 4n equal to another direction 4. So the n equal 4 over 4 equal 1. It is an integer number. So it is the aromatic compound. Aromatic compound. Let's take another examples. Maybe the compound like this. draw it better. Single, double, single, double, single, double. Okay, double, single, double, single, double, single, and single. For this compound, let's start double, single, double, single. This carbon atom, double, single, double, single, double, single, double. There is no double, so it will not aromatic. Firstly, let's talk about the Huckel's rule. 4n plus 2 giving to us 2, 4, and 6. I'm thinking I have an else one pi bond in this case. So let's draw it by a correct way. تعالوا يا شباب هرسمه بطريقة أفضل من كده. هاخده في ورقة بره. ثواني أشوف السلايد اللي أنا كنت مجهزها لكم. مش دقيقة. I think this. I think this slide. Okay, let's talk for this compound. Aromatic or not? For the Hooker's rule. Firstly, when I have the single, double, single, double, single, double. 4n plus 2 equal the number of pi electrons. 1, 2, 3, 4, 5, 6. Decollize the electrons? Yes, it decollize the electrons. Cycle, let's have the cycle. Each carbon atom must contain one pi bond. For this carbon atom, one pi. This carbon atom, one pi. This carbon atom, one pi. This is pi. Carbon atom, one pi. This carbon atom, one pi. This carbon atom, one pi. This carbon atom, there is no one pi. So, before starting to talk about Hooker rule, it is non-aromatic. For this compound, this carbon atom, carbon, 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 carbon. This carbon atom, there is no pi bond, but at least it's have a one positive. So it is called the aromatic. And so on according to this. Okay. Said the integer number, شباب, must be 2, 4, 6, 10, and 14. This is for the aromaticity and the Huckel's rule. This is the finish our session today, inshallah. The next session, inshallah, with the girls, we are going to talk about the alkenes and alkynes, and we'll attaching this to you, inshallah. See you soon. Assalamu alaikum wa rahmatullahi wa barakatuh.